using thread pool and the callable interface. So there's one shortcoming of using the thread class, which is you cannot return any value because the ram method, it doesn't return anything. Also, it doesn't have any exceptions. So what if I want to return something here, right, to the main thread or to the thread that is calling this class? So in that case, we have to use a callable interface. But callable interface has it's not a parameter in the thread. So the thread class, right, it only takes runnable. It doesn't take any callable. So in Java introduced two mechanism or two different classes. One is a thread pool that it can use thread pools to create threads and create tasks, and the thread pool can take a callable interface and it can return. And since the return is not immediate, right? So then Java also gave us a future class that we can use future class to take the return in a stub. So by calling the get method, we can get the value from the thread from the callable interface, which is executed in a different thread inside the thread pool. So we just used two steps. First, we're gonna create a thread pool. Okay, create thread pool in Java. So there is a class called executor. Okay, so this is a utility class that we can use to create thread pools. Executor start, we have a fixed thread pool, we have a cached thread pool, we have scheduled thread pool, we have a single thread pool. Okay, so that is for different usage. So basically for the fixed thread pool, it always gonna maintain 10 threads inside the pool. So every time we can just submit the tasks to the pool. Okay, so executor service class, okay, is actually interface. It's a reference to the thread pool itself. Okay, so then this is the line that we can create a thread pool using the utility class executors, and then there's a utility method called new fixed thread pool. Then we can create a thread pool with 10 threads, and we use executor service as the reference, okay, to handle the operations. And then here, then we can just have a execute or submit method. Okay, so it depends. Let's see, the execute, it doesn't return anything. Submit, it returns a future object. Okay, so we can use this one, and it takes a callable. Okay, a callable object. So we can just call it a task, and then we can just have a lambda, for example, to implement this callable interface. Okay, so it's a functional interface too. So we can use lambda, and we have to return something. Right? So let's see, we just return a number 1. Okay, so for example, and then we can just put task here. Okay, and then we're gonna have a future object that it will handle this return type. Okay, we already know it's just one, but you can just write a more complicated code to return some other objects. And then we can, or maybe we can make it a little bit complicated. We can return apple, okay, class, object, sorry. So then we can just write our apple here, okay, and just make a string color, for example. Okay, and then the future will be holding an apple object. Okay, so there's a lot of warnings there, is because I'm not writing like the most efficient code. So because this return, for example, it can just simplify to this. Okay, it's a method reference, but we didn't talk about this yet, so I'm just gonna write it like this. And this callable is a raw, so we have to put the generic type here. Okay, so actually the whole line can be simplified into apple new, right? So here we don't need to have this task line there. But anyways, so to make it more easy to read, okay, so here is the code. And now we can print out the method. So this get throws exception, so we need to make sure we handle this exception properly. Okay, for the time being, I'm just gonna throw it out. And now if we run the code, okay, so it print out this apple. And we can actually, before return, we can print out the current thread. Okay, get name, get the current thread, and you see I didn't shut down this thread pool, so then my code is still working there. Okay, even though everything is down, the main method is down, but the thread pool is not closed, so my program is still running there. Okay, so because I forgot to shut down our thread pool. Okay, so now if we run again, okay, now it's shut down properly, and also you see the thread name is pool 1 thread 1, right? So this is the line printed out here, okay, in the tasks. But when we do f.get, right? So here, then current thread.get name. So this will be the main thread, right? Because the main thread is trying to get the result from the future object, which is the stub of the return inside the task, inside the thread pool, okay, which is running this task. So this one, again, it will print out main. Okay, so you can see main. Main method got this object. Main thread got this object, but this object is generated inside the pool thread, okay, thread pool. So this is the way that we can use a simple thread pool to control the size of the threads so that the thread number won't go out of control, and also we can just retain the resource on the server. And also we can handle the return type, and also this callable interface, okay, it throws exceptions, so we can also give the caller exceptions that are supposed to be thrown. Okay, so the thread pool is the most commonly used technique in the server side instead of creating thread class or creating a runnable interface. It is because this is a more like a safer way, efficient way, so that we don't have to keep creating new threads, which take time and also very like easily get out of control, because you cannot know how many threads are going to be created if you create a thread inside a method and you don't know how many times this method will be called. Okay, so but mostly it's like for this thread pools, they don't kill the threads, right? It's like if you don't shut down, then those threads, they will be running there waiting for tasks. Okay, so you don't have to spend time to create the thread every time you need a thread. So the threads are already created, so you just keep reusing it. For different types of thread pools, so we have a fixed thread pool, we have a cached thread pool. Fixed thread pool always keep 10 threads. Cached thread pool, it will create the threads that you need, and it will wait there for a little bit, okay, for a certain amount of time. Actually, we have a, you can see keep alive field is 60 seconds, okay, so like 1 minute, okay, and also if you want to customize the usage of the thread, okay, so like all this cached thread pool, fixed thread pool is not suitable, then we can use this thread pool executor. Okay, so this is the main constructor that we use to customize the thread pool. Okay, so because thread pool, it contains a pool itself, contains a queue for tasks, and also it contains all the parameters like live maximum pool size, right, minimum keep alive time, how much time the thread will be there. Again, for here you can see if we use fixed thread pool, it basically create a n number of thread, okay, and keep minimum maximum that number, and keep the core pool size that number, and also keep alive for 0 means that forever, okay, and also it use a linked blocking queue to save all the tasks. Okay, so those are the parameters that we can use to twist this thread pool to meet our requirement. So if you want to simplify, just use the executors class, and they call this method new fixed thread pool or new cached thread pool. If you want to customize, you go to this class, okay, new keyword thread pool executor, to pass the parameters that you want to customize. Okay, so that's it for the thread pool.